Hi, this is the demo of GIS project that was part of the CSS 590 course, Geographical Information Systems, taught by Professor Muhammad Ali. Our topic was trajectory-based friend finder application, and we were a group of 6 people: Keith, Priyanka, Agranee, Fatma, Priyadharshini, and Preethi. Let's look at the details of this project right now.
The basic idea is to look at the traces and abstract information. Of course, there's such a wealth of information, but early on we realized that a fundamental approach that would simplify the data to a manageable size would be to just look at the location that users spent time in. So you could look at the number of visits, the duration and the frequency of visits, and the locations of the locations that were visited to determine the fit. And then you could come up with any number of criteria really based on that. So then we worked on coming up with friend recommendations based on the criteria, looking at the trajectories of the different people and the time, location, and visitor information for each user. We'd compare them and then make a recommendation based on certain similarities. But really, once that table of similarities is built, any number of criteria could be developed.
Let's look at the architecture of the friend finder application. This is an MVC architecture. We have the client, the web server, and the stream insight server. Essentially, the web server and the stream insight server are hosted on the same server, but just for the sake of explanation and easy understanding, we have them as two different components in the diagram. So the client web application is our client side, which is a web application, which is just a website. When you give the inputs from the client side, all the criteria inputs which are fetched from the end user are passed to the web server. So what the web server does, it will fetch all the criteria inputs from the client application, and it will pass all these criteria inputs to the stream insight server. The stream insight server is the main part which has whole logic. It has 3 main components. The first one is the XML parser. The XML parser is a component that parses various XML files which are as inputs to the system. So you have various GPS traces of users that are in the form of XML. This data is parsed using the XML parser component, and we fetch the latitude, longitude, and the timestamp information from the input files. Once we have all this information ready, we have these traces ready. From this, we use the stream generator component to generate a CEP stream, which is the stream insight stream, so that we can use this stream for various criteria. The third component is the criteria evaluator, which is nothing but works on the stream generated by the stream generator, and it just does various math and some link queries to find the specific friend for the user based on various criteria algorithm. Once we have the criteria evaluator working, we'll get a friend's ID as a recommendation for that specific user. This ID is sent back to the web server, and from the web server, we retrieve the user information for that specific friend ID. We get the user name and his email address, and that is sent back to the client and is displayed to the user as the result.
The user interface is implemented as a Windows Azure website. The idea being that you have standard technology and universal deployment. You can see it on smartphones or laptops or desktops or supercomputer, whatever. We use the .NET Model View controller application, and that's allowed for isolation of design concerns and a tremendous amount of infrastructure provided by the framework. The website is at friendfinder590.azurewebsites.net, essentially worldwide deployed, although it's actually in sandbox mode currently. We did authentication using Facebook as an authentication provider, as well as local authentication. The user information, name, email, and ID, and then there was a personal weighting of criteria 1 through 4, even though all those criteria are not completely implemented. The friend recommendation is provided, and then ultimately something to build on with this would be a geographic representation of both you and your candidate friend with the points of interest similarities. But and here is the website. For example, we could make up some username, say Harry Harry at some bogus password and then try to log in, and no, we don't want to remember that password. And no, that doesn't work. Okay, well let's go back here. Let's register Harry. We'll give him a quick password, not of the intense security, but and now we register our Harry. And there we are. Now we have a default vector here, which is 100 on the geographic proximity pattern, and then the pattern similarity, shared activity type are all at 0, and you can elect to find a friend. It recommends John Doe at email.com. That's sort of a bogus recommendation based on the fact that while the website works, it's not fully integrated to the back end. We can go back to the home, and we have create, edit, etc. So, for example, we can delete our, oops, no. At one point, we could delete our user. But anyway, that is the website as it currently exists.
Moving on to the criteria, the number one criteria would be geographic proximity, in which this application would be finding a friend, basically a closest user to the one who is logged in into this application. So let's move to the demo for the criteria one. I'm going to build the project first. And then run the project for criteria 1. So yeah, in the background, the criteria 1 is checking all the users and then finds the geographic distance from the the distance, the nearest geographic distance between the logged in user and all the users, and then it does a comparison to find the closest friend. So here we get the output for criteria 1, which finds the closest friend for Kevin William, and here it displays all the information for friend, who will be John Smith, and these are the contact information. Let's move on to criteria 2.
criteria 2 is to find similar activity based on duration. This criteria finds friends who spent same amount of time at same place. For this, we first sort the places by duration in decreasing order for each user. For each user, then we select the place where they spend the maximum amount of time and find if two users spend their maximum amount of time at the same location. And this is done by finding the intersection of the polygons. Let's look at the demo. For this, we query a table and find out the maximum duration that the users spend, and in return it gives the polygon where two users spend the maximum amount of time. So here we can see that users are spending a same amount of time inside a specific polygon. Now let's look at the criteria 3. In criteria 3, we find friend based on a given duration. So for this we require a table that will contain the user ID, duration and the place. And for creating this table, we analyze the traces to find the stay points with threshold distance as 100 meter, threshold duration as 20 minutes. After this, we create the stay region corresponding to this stay point by creating a polygon after finding the latitude, longitude for the north, south, east, west boundary by adding a constant value of 0.0045. This value corresponds to the change in latitude, longitude for a change in a distance of 100 meters using the formula where theta is equal to length by the radius. And insert the polygons into the table. And now let's have a look at the demo. For this, at first we insert the values into the table by finding the stay points. So right now it is inserting, and then we find out the place where a user spends more than 30 minutes and see if any other user also spends the same amount of time at the same polygon. And we find that yes, there is one more user who spent the same amount of time at the same polygon.
So this is the friend finder application that we developed, and I hope you enjoyed watching the video. Thank you so much.